Welcome to the StormSurf Video Surf Forecast for the week starting Sunday, January 11th. Looking at significant wave heights for the North Pacific Ocean, we see an area, 31-foot seas, northwest of Hawaii, but really part of a broader, complex gale almost filling the entire North Pacific Ocean, other than the immediate coast off of California and the U.S. West Coast. Low pressure, this area, high pressure here, suggests that the jet stream is in fact pushing well off Japan, but is split off the U.S. West Coast, keeping things high and dry, at least for the moment. Let's dive into the details. The current jet stream configuration has 200-knot winds pushing off of southern Japan, dead flat to the east, reaching almost to a point, or actually past a point north of Hawaii. That's at about 150 west, before it starts to split. These winds are very strong, provide good support for gale development. All we need is a trough, that is some sort of bow in the jet, and you can see it just starting to happen here, that would support gale development. That is counterclockwise circulation at the ocean surface. Here we are up at jet stream level though, 30,000 feet up. What we also see is a split configuration east of 150 west, so that suggests high pressure at the surface, and that is in fact what's happening, protecting the U.S. West Coast and Canada, keeping things relatively high and dry. Let's put this into motion, see how things play out. The jet stream continues very strong in about the 190 knot range into Monday and Tuesday. A bit of a trough, a dip trying to get going here on the dateline, supportive of gale development. And notice, a little bit at a time, the split point here where we have one branch going up into Canada, one branch down into almost Mexico. This starts easing its way east as we move into the week. Winds continue very solid, 180 knots, good support for gale development. Trough gets a little bit better defined here by Wednesday, 72 hours out. And as we continue, notice most of the wind energy now is pushing more to the east, north of Hawaii, and notice the split point by, let's take it out to Friday morning, reaches 130 west. That's less than 600 miles off the central California coast. And notice at this time, also, more wind starting to build over Japan. This very much looks like a jet stream that is supported by the active phase of the MJO. Notice no splits anywhere else, no odd configuration, just a flat-out, hard-running jet pushing west to east. This looks very much like the MJO, if not maybe a little bit of enhancement from what would be considered a weak El Nino. We continue to roll this out, and it just continues going. If nothing, the winds off Japan by Saturday night, a week from now, start looking stronger still, and the main push here starts moving into California, and that suggests perhaps weather for the U.S. West Coast. And then we roll this out, continuing into 180 hours. We now have 170 to 180 mile-an-hour winds in the upper levels of the jet here off Japan, working their way to the dateline. A bit of a weakening here in the East Pacific, but still the expectation is these winds will continue working their way to the east and continue to fuel storm development. Notice no real clear-cut troughs at all during this entire week-long period, but just wind speeds alone and the rather southward position should do a lot to fuel gale development. Next, we take a look at surface level pressure and surface level winds. Notice, as we suspect, low pressure filling almost the entire North Pacific Ocean, other than a small area here in the East Pacific. A gale, 45-knot winds, positioned north of Hawaii, providing fetch and generating seas of interest. Some of it aimed towards Hawaii, more like sideband energy, and most of it pushing towards the U.S. West Coast, but a bit further away. Behind this, just sort of unorganized fetch, 30, 35-knot winds, good for swell, certainly for Hawaii because it's in closer proximity, but nothing super organized, nothing really strong. Let's put this into motion. So we roll it out. The gale north of Hawaii fades out by Monday. Looks like a new gale starts to organize here west of the dateline on Monday as well. It continues pushing to the east, but nothing's real great. 30, 35-knot winds. You know, we want to see 50-knot winds, and we're not seeing it at all, or even 45-knot winds. Just the same. Continued fetch. Look at this. By Wednesday night into Thursday morning, a large area of 30 to 35-knot winds targeting Hawaii. Certainly good for probably 13-second period swell, and a lot of it. Anyway, we roll this out into Friday. Things sort of back off a little bit. This is about the time that the jet starts fading in the East Pacific, but then it starts rebuilding under Japan, and let's see what happens here. Sure enough, here comes another gale. Now, this is actually a storm. 55-knot winds projected almost a week out. That's Saturday night, the 17th, and pushing towards the date line. And that's about the end of it. So 180 hours out. Of course, very unreliable this far into the future. But the models have actually been doing a pretty good job lately and have held reasonably well. Once a storm pops up on the charts and gets a day or two of traction and it appears that, it's stable, something normally does develop. So the thought is there's a lot of potential for small to mid-sized swell development, and then maybe something larger come about a week out. And that's about consistent with what the models suggest in regards to the MJO, and when the MJO really starts getting, the active phase of the MJO starts getting good traction over the North Pacific. So we'll see how that plays out. But certainly at the surface, and using these models, things look encouraging. Let's go take a look at significant wave height projections. So now we'll take a look at significant wave heights. We're going back to Saturday night, just not even 24 hours ago. Small gale starts developing on the dateline, 22-foot seas, and as we move this out into about current time now, we see 31-foot seas north of Hawaii, more or less. Let's see, 335-degree path. And not too far away either. What is that? About less than 1,000 nautical miles, 850 nautical miles or so. So certainly swell looks like it's already in the water, pushing towards Hawaii. But the interesting part about this is actually most of the fetch is aimed to the east. That's sideband swell for Hawaii relative to California. 280-degree track into Northern California, and about the 287-degree track into Southern California, but a long ways away, the better part of, let's see what we have here, about 2,100 nautical miles to Northern California and about 2,400 miles into Southern California. So much less size expected for the U.S. West Coast, just given the distance and more decay. Anyway, let's put this into motion. It sort of peaks out here tonight, 32, 33-foot seas, and then fades out quickly. Then we go into yet another fetch developing here over the date line, 20, 22, 24, let's say 25, almost 26-foot seas, and very far to the south. If this were to play out, this would be a very west-angled swell relative to Hawaii. What's that? The 292-degree track into the islands. That almost might be, that just barely make it into the north shore of Oahu. Anyway, we roll this out, and that builds a little bit to 26-foot seas and gets a little bit more of a north angle on it. Not much, though. Really, still 292. We'll just put this into motion. Then it fades out. So most all that energy is about the 292-degree track to Hawaii. Some of that, so we'll roll this back just for laughs and see. Relative to the U.S. West Coast, it's 285 degrees or less, 282, but notice the swell vector here is mainly aimed at Hawaii, so probably not a whole lot of size for the U.S. West Coast from this one. Anyway, that fades out. Another broader area. This is the 30-35 knot fetch that we saw later. This is on Wednesday night. Again, takes aim at Hawaii on about the 305-degree track, and pretty much then tracks north of the islands, fades out. Again, notice all the activity is more the dateline, Western Gulf, nothing making any good penetration towards the U.S. West Coast until we get 156 hours out. And then this is that one solid storm that we saw forming off Japan on Sunday. 43-foot seas, let's see, that's actually 44-foot seas relative to Hawaii. That's on about the 306-degree track and aimed well down the Great Circle paths there. And relative to Northern California, reasonably well up about the, hard to see it here, about the 290-degree track or so, 291, something like that. and to Northern California. And it's supposed to make pretty good progress, at least make it to the date line. So we'll see how that plays out. But generally, it looks like there's good support for swell development, mainly targeting Hawaii, but a lesser energy into the U.S. West Coast. Not bad at all. Next, we'll take a look at longer-term indicators. What's going to happen over the next 2 to 3 to 4 weeks? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. This gives us some sense of what's going on with the Madden-Julian Oscillation. When the MJO is in the active phase, it supports storm development in the North Pacific in winter months, and we are in those months. And if anything, the daily numbers are about 1.37, kind of neutral. But the 30-day running average is at minus 6.31. That suggests that we are in fact, the active phase of the MJO. And the 90-day running average is minus 7.89. It has been in the minus 8 range since about mid-October. So we're going into 3 months here of negative SOI numbers. That suggests that some sort of El Nino is in play when you get this long running average in the negative category. That's exactly what we want to see. Whether this is enough to constitute a real El Nino or not is another discussion for another day, but certainly we're in the right configuration to support storm development. Here's another way to look at the trend. This is the 30-day Southern Oscillation Index, but mapped over about a 2-year period. Notice here in 2013, we were in basically La Nina range. Positive numbers. This is a 30-day average, so it was basically all positive until we hit the early part of 2014. Things dropped negative. We sort of lost a little ground there in the spring, but then here we go. Since July, things have been negative, and now we're moving into 2015. SOI still negative. What we're hoping to see is this continue into 2015. We think we're in what we'll call a Midoki El Nino situation. Sort of El Nino, but not really. Just not quite strong enough to be officially declared El Nino. But we'll watch these numbers and other indicators to see if we can get into, let's say, the spring and early summer time frame, still hanging down here somewhere in the negative range. If that is in fact the case, that bodes very well for next fall and next winter. So we're already looking for indicators in the tea leaves for what could be happening up to a year out. Next, we're going to look at surface level wind anomalies, differences from normal. When the active phase of the MJO is occurring in the West Pacific, you typically see westerly anomalies. That is, the wind trades typically slack on the equator, and we're really only interested in this little area here on the equator, and this is going back to January 5th. The oranges and reds are westerly anomalies. On the 5th, we see them, on the 6th, on the 7th, on the 8th, and building into the 9th. And now here we go into the 11th of January, a better view, closer in, solid west anomalies from almost the Indian Ocean, almost, here's the date line here, Australia here, the Philippines here, westerly anomalies on the equator, looking very good and actually getting good, making good inroads to the south. This is actually what we would consider a westerly wind burst. Now, as we go to the east, things sort of back off. Once you get to the date line, things go neutral. And as you work your way, so here's Hawaii again, and you work your way east, there's actually easterly anomalies. This is the inactive phase of the MJO, and it's working its way off to the east in the East Pacific. This is what's probably feeding the high and dry pattern over California. Literally, where the east winds are, north of there, it'll be high and dry. Where the west winds are, north of there, you'll see more storminess. And this is exactly what we're seeing on all the surface level models, wave models, everything. Suggests the pattern's more set up towards the datelines region. And then in the east, it's high and dry. Anyway, we go a week out here. Let's see what's forecast to happen. Now, here is westerly anomalies. A little bit of easterly anomalies are suggested over about 160 east, but then more westerly anomalies on the date line. And then as we continue off to the east under Hawaii, westerly anomalies, and the easterly anomalies that were south of Mexico are completely gone. That suggests a week out that really the MJO is going to be taking over the entire Pacific Ocean. Here's yet another way to view this. This chart, reds, purples are westerly anomalies. Blues are easterly anomalies, but here's the scale, and what the Pacific Ocean is pretty much, take it from about here to about here. The Galapagos would be here, the Philippines would be off here. You can see in December, the active phase of the MJO was effectively in the Indian Ocean. And then starting in January, it started to move east. Here's our westerly wind burst that is occurring right now in the far west Pacific. It suggests that it might fade out a little bit, but then also move a little bit east. It's kind of a fragmented thing. This is the way the MJO works. It's not just a solid blob like a storm that moves west to east. Kind of flares up, fades off, flares up, fades up, and not always completely coherent as it makes its way to the east. Here's another projection of where the MJO is going. This is over the next 15 days. The blues, this is outgoing long-wave radiation, but still another measure of the MJO. So blues represent less sunlight reflection off the ocean surface. That suggests cloud cover, and that suggests the active phase of the MJO. Here we are currently, and it is depicted north of Australia, with the inactive phase working its way east and fading out. Over the next 2 weeks, you can just about draw a line. This is the statistic model suggesting that the active phase of the MJO is to work its way to the dateline over the next 2 weeks, while the inactive phase starts building in the Indian Ocean. The dynamic model is not as aggressive and not as strong, suggesting that the active phase is supposed to sort of stay here in the West Pacific and not make a lot of eastward progress, but it also suggests that the inactive phase is also supposed to stay bottled up in the Indian Ocean. And yet one more view, this is up at jet stream level. The greens represent the propensity or the potential for precipitation. Again, West Pacific, this is the active phase. The greens, the reds and yellows and purples in this case are the inactive phase. This model suggests the active phase working its way east into about the end of January, and then the inactive phase takes over, works its way across the Pacific, and then we have yet a new active phase coming in maybe in the 5th to 10th of February. This is interesting. So basically, the active phase of the MJO is going to rule everything except for a little window here from about, let's say the 28th of January into about the 10th of February. So about a 10-day down period, and then we get some influence again. It'll be interesting to see what really happens. Next, we dig in a little bit. We're interested in El Nino. There's been a lot of thought that El Nino is trying to get organized. We look at one of the main indicators for El Nino is surface temperature, sea surface temperature anomalies, differences from normal. What we're seeing now is light, warm anomalies, and it's specifically in the area from 120 west to about 170 west, and just a couple of degrees either side of the equator. Put a box right there, and that's what we're looking for. And clearly we see light, warm temperatures, but nothing particularly strong. In fact, you can average all the temperatures in this area and find out really what the anomalies are. And here you go. This is the Nino 3.4 index, and notice water temperatures are darn near normal right now. Just, they've been above normal, up to a degree above normal back in November, but they've been crashing lately, not going negative, but just holding neutral, and that is because we believe we are in the upwelling phase. We're in the upwelling Kelvin wave phase. It's not surprising to see these temperatures drop off when that happens. Another sign of the upwelling Kelvin wave phase is notice water temperatures off Peru are not warm anymore. It was all warm along here. It's starting to cool off a little bit. This is expected to be a temporary cooling, nothing significant, but what this also suggests is it's going to be very hard to reach the criteria, the minimal threshold for an El Nino this year with temperatures dropping off. You need 5 consecutive months of 3-month running average, and it just doesn't look like it's going to happen. But that's okay. This is classic Modoki El Nino, kind of acting like it's El Nino, kind of not. But you know what? These water temperatures are still helping to fuel the jet stream. They're still helping to fuel the MJO. Things are going on supportive of storm development, though it hasn't been an over-the-top year at all, at least in the Pacific. There's been some decent-sized swell swells, but nothing over the top. We're wondering if it doesn't come here in once the, as we're getting into this active phase of the MJO, if it doesn't happen here in late January, we're not sure that it really is going to happen. Still, we're in way better position than we've been in the past 3 years, where there's all cold water here, and really there's almost no storm development, and the North Pacific is all choked down by high pressure, and there's no rain. We're past that. I mean, we're actually in a pretty good place. So the atmosphere is healing, moving more in the right direction, just not doing it fast enough for most of our desires. Anyway, zoomed in sea surface temperature look on the equator. Here's the West Pacific, here's the East Pacific. This is anomalies. This chart is actual water temperatures, actual wind speeds. Here's the anomalies. Here's your westerly wind anomalies in the West Pacific. Kelvin wave probably being generated. Westerly wind burst for sure. Notice water temperatures here, 0 to maybe half a degree on the equator. That's it right now. And then warmer here in the west. And next, the subsurface temperature profile. What we're looking for is Kelvin wave. And what is a Kelvin wave? It is warm water that migrates west to east at depth across and under the equator, across the entire equatorial Pacific, generated by westerly wind anomalies on the surface. You get westerly winds, just like what's happening right now in the West Pacific. That pushes warm water to depth. It makes the journey the whole way across the Pacific, gurgles up along the Galapagos Islands, and then starts warming the equatorial surface waters, and that is how El Nino really gets going. So this is the actual water temperatures. This is anomalies right here. You see, generally warm. This is a little bit troubling here, this 1 degree below normal, but generally speaking, there's a clear open path for warm water to make its way across the Pacific. The last little remnants of a Kelvin wave that was generated 2.5 to 3 months ago is gurgling up off the Galapagos, but not doing a whole lot anymore. And there's no big pocket of really warm anomalies indicated at the moment. But westerly winds anomalies are occurring at the surface. The expectation is that will build this pool of warm water here, and we'll end up with another Kelvin wave. Here's yet another view from a week ago, the last of the Kelvin wave working its way over the Galapagos. Notice warm water here in the very far West Pacific, warm water here. We think this is early signs of a newly developing Kelvin wave, and we have yet one more chart to sort of nail that one down. So here we go. This is a little bit of a historical look. West Pacific here, East Pacific here. The reds and oranges are warmer than normal water temperatures. The blues are colder than normal water temperatures. This is upper ocean heat anomalies. So this is the top 300 meters of the ocean, and you look and it's differences from normal for this time of year. Clearly, at the beginning of February 2014, massive Kelvin wave made it the whole way across the Pacific. Then we had a cool down, the upwelling. This is a downwelling Kelvin wave. Upwelling phase, temperatures back off. A little mini Kelvin wave in August, yet a stronger one in October, finally erupted in the Galapagos in December. And now here we go. Here's the signs of perhaps another Kelvin wave getting going. This is the upwelling phase right here, and this is what is occurring south of Hawaii right now, sort of cooling off a little bit. We're hoping that westerly anomalies continue to build over in the far West Pacific and set up yet another Kelvin wave. It looks like that is what's occurring at this moment in time. So this is good news. That means about 3 months from now, warm water would start erupting off the Galapagos. That would be roughly, let's say, mid to late March or so. So something to look forward to. It's interesting if this whole event was our El Nino. Typically, you go into some weak form or even a moderate form of La Nina after El Nino. So we would not be expecting to see more Kelvin wave activity in the West Pacific. El Ninos typically peak out about the end of December. If anything, we'd expect to see easterly anomalies building and temperatures starting to drop. We're not seeing that. It looks like we're moving on a continuation of what's basically been going on all year, just sort of these weak westerly anomalies, trade suppressed, warm water making its way west to east. That, again, fuels water temperature warming in the Nino 3.4 region, and that helps fuel the jet stream. And if that were to happen for a second year in a row, you get more momentum build up in the jet stream, maybe even help supporting the southern hemisphere winter season. That would be the June-July time frame, and maybe a little bit better storm track down there than we've had for the past couple years as well. But again, the pattern is basically weak, kind of muddled, not real sure. It's certainly not, black or white. It's kind of not sure where it's all going, but it generally looks like it's headed in the right direction. And finally, the Nino 3.4 sea surface temperature anomaly forecast, long range from the CFS version 2 model. Here we are in early January. Water temperatures per the model are suggesting we should be at about 0.6 degrees. We've clearly seen, though, that we're down at basically down here. The question is, what's going to happen? This model suggests water temperatures basically hanging in the, let's say half a degree anomaly range through the spring. And then as we start getting into summer, water temperatures start building. This would suggest at least here, some sort of weak Kelvin wave activity, and then major westerly wind bursts and major Kelvin wave activity as we get into the summer, culminating probably in some significant El Nino next year, according to this model. None of the other models suggest that, though. They all suggest some sort of just a slow sort of continuation of about what we have right now, which would be perfectly fine, perfectly acceptable. If we had another year like this, I'll take it. It's better than where we've been. So the future is generally optimistic, certainly not negative. We'll go for it. So to wrap things up real quick, near term, looks like swell on the way. Nothing huge, nothing defined. Hawaii to be the focus. California to get continued small to modest size swell. Potential for rain perhaps a week out as the jet stream starts moving onshore, but it kind of looks like the jet stream will back off a little bit in California and rebuild in the West Pacific. Stronger storms forecast there. So the immediate future looks pretty good. Stretching it out a little further, the MJO is to continue to pulse. More support for storm development, let's say the next 2 to 3 weeks, which would be good, and is pretty typical of the MJO. Then perhaps a break, and then perhaps more activity as we get into early February. So for now, it looks like pretty good pattern. Certainly worthy of going out and getting some waves. So that's it for this week. Hope you've enjoyed the forecast. We'll do this again next week, same time, same channel. In the meantime, go get some surf, have some fun. See you next week.